Hey everyone, it's Reza. Welcome to part 2 of our dive into modeling tools in Unreal Engine 5.4. Last time we explored the Create, Exform, and Deform tools. In this session, we will cover the remaining tools and demonstrate how to incorporate them into your modeling toolkit. Let's jump in. I'll be using the same scene, the same level as the previous session to demonstrate the remaining of the tools. Now the first one on the list is Model, and the first tool within the tool category is Polygroup Edit. Now I kind of tried my best to skip Polygroup for this session to thoroughly explain that, as polygroups play a huge role in your modeling. Now, what is a polygroup and why we have that in Unreal Engine in the first place? To demonstrate that, let's open Autodesk Maya, and I'm just going to put a simple sphere in the scene. Here I am inside Maya 2025, nothing too special. I've got a simple sphere with utility node applied to it so you guys can see the resolution. As you can see, by default in many application packages like Maya or Blender, as soon as you create a geometry, it's just so natural to get evenly spaced quads. Throughout the modeling process, we try to emphasize on the importance of that, and we try to warn all the students not to have any n-gons, to have clear topology, so on and so forth. Now let's select this sphere and export it to Unreal Engine. I'm going to go to File, Export Selection, Option box. FBX is my file type, Export Selection, and I'm going to simply call that Sphere. Export selected, close. Let's switch back to Unreal Engine and bring in this sphere. Here I am inside Unreal Engine. I'm just going to right click, import sphere, open. With the default settings, I'm going to import all. It brings the material. We don't care about the material. Let's bring in the sphere. It's very tiny, so let's scale that 25 times. Right. Now, we already learned how to inspect the geometry. We go to Attributes, we go to Inspect, and instantly you see the difference. This is no longer evenly spaced quads, they are triangles. Everything has been triangulated. If I zoom in, you can see that clearly. The reality is the conversion to triangle means Unreal Engine does not natively recognize quads or n-gons. And it is really important to understand that and to be aware of that if you would like to work with polygroups. Right now, Unreal Engine is not quite sure how to deal with this sphere. If I go complete and go into Model and go into Polygroup Edit, you have a bunch of tools that you can apply specifically to polygroups, but since this sphere has been brought from another DCC, Unreal Engine is having a hard time understanding it. It sees everything as a single polygroup. And that's why it is important to understand what a polygroup is, how to create your own custom polygroups, and how to benefit from them once you understand them. For example, if I go into Mesh, I can create my own polygroup. I can go into Try Select, and now Unreal Engine understands triangles. You can just click and drag and select a bunch of triangles. And if you're making a mistake, you can hold down Shift and paint again. And once you're done with that selection, within the mesh processing tool category, you go under mesh edit and you create your own polygroups. Now on surface nothing happens, the shape of the sphere is not going to change, but if I accept, now go back into model and polygroup edit, all of a sudden the area that we marked as a new polygroup is visible to Unreal Engine. So I guess it's now easier to say that polygroups are a set of grouped triangles that you specified, and those polygroups can be used for variety of tools. You can apply extrude, inset, bevel to them in modeling and deformation. You can use that within your material organization, and you can even benefit from them during UV layout here in Unreal Engine. With that out of the way, and with you understanding fully what a polygroup is about, let's move on to the next chapter and start with the model category. Let's start easy. Let's start with predefined shapes. Polygroups are automatically generated on predefined shapes in the create category. So if I go in there and let's create a box, I'm going to increase the height by 200 and let's place that in. So everything is ready to go. Zoom back and rotate. Now if I go into model, polygroup, you can see that Unreal Engine already sees faces. I can switch to edge, then I can see points and select them if I want to. The power of that is now it's all accessible to me and I can use all of these tools. Let's say I'm going to select this one right here and I'm going to inset that. And it's going to sort of extrude that in ever so slightly. Once I'm happy, I'm going to accept. And guess what I have? A new polygroup. And I've generated 4 extra polygroups. I can repeat the same scenario. Select the polygroup and extrude it out and generate a new one. I'm going to go accept. I can filter only to the edges. Hold down Shift and select these edges and now go bevel and create a bevel. I can go change the bevel distance if I want to, round corners if need be, although for round corners you need to have subdivision. There you go, and it's ready to go. I'm gonna go accept. Now let's see what's gonna happen if I go into polygroup edit again and faces. We have even more polygroups generated by Unreal Engine. It doesn't end there, because in the shape edit, I can actually insert edge loop. If you're familiar with application packages like Maya, we have exactly the same thing. I can go in there and say, I want to create a loop here. I want to create a loop here, and I want to create a loop here. I can go into even. If I undo, I can specify number of loops that I want. Let's set that one to 3, and all of a sudden I get 3 edge loops that I can insert with a single click. Within those, I can even continue and add edge loops around the geometry. What's going to happen? Well, as a result of that, each one of these now are polygroups. I can select these two and perform the same operations on them. I'm going to go in there and accept, and then rinse and repeat. Select these edges and perform another round of bevel. So you can see how quickly you can get close to the traditional modeling, where you use a set of tools, very specific set of tools, and you continue with your work. You have tools for shapes, tools for edges, tools for UVs, including planar projection. You can select a section. Let's say I'm going to switch to face, select like this, and then I'm going to go invert selection. It opens a whole new world once you understand polygroups. It allows you to select components accurately and apply modifiers only to those polygroups. Now, what's going to happen if I bring a geometry from other software packages? When you bring an object from another application, everything is just one big polygroup, and it's your job to decompose it into multiple polygroups. And one of the roles of having mesh is just that. Now, before I go into mesh, there are a few bits and pieces that I would like to talk about, because it's not just about one tool here. We have subdivision, which increases the subdivision. So if I go into attribute and inspect, you can see the subdivision is okay. But for whatever reason, if you want to increase the subdivision, you go into model, subdivide, and this allows you to subdivide the model. I'm just going to use one level of subdivision. Subdivision scheme, I always set that to Cadmel-Clark, which is quite a common algorithm for subdivision. And look what we have, new polygroup. So you can create or assign a new polygroup ID to whatever you subdivide. I'm not going to turn that on at the moment. Let's go accept, and of course as a result of that we get a more of a softer look because we just added so much polygon. Let's go and inspect that. You can see we've got more polygons, but how's that going to impact the polygroups? Let's go into polygroup edit. You can see the polygroup stays the same. You can see the power of polygroups in situation like this. I'm going to undo the subdivision, and this time I'm going to subdivide, but I'm going to enable new polygroups. Look at the blocks, and each block with individual color is a polygroup. As soon as I enable new polygroup, it's going to adapt to the resolution, and from this point onward, all the new faces are getting new polygroups. Now if I go in here, you can see now each section is getting a polygroup. There is no right or wrong here. It just comes down to what you want. Do you want new polygroups? Is there anything that you want to do with them? Are you going to use them in UV mapping, or are you going to apply modifier to these polygroups? If the answer is yes, then you definitely need to make sure if you subdivide, you enable new polygroups. That's fantastic. I'm going to go accept. The next one is Boolean. And to do that, we need to have a cylinder. So I'm just going to drop in a cylinder, make it a tad smaller, and move that into position. And I'm going to go accept. Now I'm going to select the first model, the source model, or model A. I'm going to select the target model, the second model, or model B. I'm going to go into model, and you can see Boolean is now on. Subdivision and polygroups turn off immediately because they work only with one selected mesh. I'm going to go Boolean, and A minus B subtract the second model from the first model, and because of that we're actually getting a hole here. And this is interactive. You can actually move this up and down and adjust it before you accept. There are other modes as well, which does the opposite, subtracts the second model from the first model. The intersection finds the overlapping section between A and B, and of course union is going to merge the two, combine the two, which is something that you may want to do. Now the next tool is called Polycut, and Polycut is a great way to create holes also within your geometry. As a matter of fact, it's much simpler than Boolean. But of course, Boolean doesn't just create holes and cuts within the model. To demonstrate this better, let me just create a brand new cube and bring it into the scene. So I'm going to go box, and this time I'll make sure to reset this setting, and I'm going to go into model polycut. And as the name suggests, it just performs cuts using extrude polygon. So if I go and look at the top, you can see we have that cut, and this cut has been performed by this imaginary plane, this grid that you see here. You can reposition that grid either here, or you can use 90 degrees in x-axis and perform the cut here or here, and you can rotate this 90 degrees in y-axis and have the cut here. For example, I'm going to go and snap to 90 degrees, enable my snapping, and rotate this plane, and all of a sudden I'm performing a cut here. You may say, well, is that just circular? That's what we're going to get. No, in the shape, you can actually select circle. You can go quads or square. You can go rectangle and position that however you want. And the good thing about that is not really boxed in within the measurements that's been given to you. You can all go in here and open up both sides. You can have something like this. It's totally up to you. You can go round, which is pretty neat, or you can go custom. In custom is where you actually draw your own shape and it creates that hole for you. With circle, it's a bit segmented, it's a bit choppy, but of course you can always fix that by increasing your subdivision and get a much cleaner result. With custom, you can go into custom and draw polygon. Let's say I want to create box in here, and from this point onward you have access to that polygon scale. Push this one back and you can move it forward, and you can see how we create a hole based on our custom shape. We have operations, cut through and trim, which only leaves the area that you have drawn behind. Insert polygon is going to actually create a polygon, and the default is cut through, which is mainly the real purpose behind having this polycut tool. But other options are available to you as well. So really powerful, this polycut. Especially the one that I really like is a rounded rectangle. And the beauty of having that rounded rectangle, if I just bring that up and move it here, is when I accept and go inspect the tool, it does take care of the triangles for me. So again, as I said at the beginning, Unreal Engine doesn't really care too much about n-gons. Everything will be triangulated. It doesn't understand quads either. So this will get compensated behind the scene, will get fixed. And if you have doubts ever, you can always go and inspect the mesh to make sure it's healthy and there is nothing wrong with it. Perfect. Now we know what polycut is and how it performs. Let's go into plane cut. I'm going to remove this and start with another predefined geometry. Let's bring a simple sphere into the mix. Old habit of mine, I still tend to drag and drop. It's just a single click. All right, let's go into model and plane cut. And what it does, it creates the same imaginary plane as polycut, but it's an infinite plane. So it no longer offers you a circle, rectangle, or rounded rectangle or custom is just an infinite plane, and that allows you to perform cut. And that's great if you would like to take out a chunk of your model immediately. It's not going to hide it, it's actually going to delete it. So if I go accept, now what I have is more of a hemisphere as opposed to a full sphere. Now we know how plane cut works. Let's go into mirror. Now mirror reflects a mesh along a given plane to create a new geometry. It's not going to combine it, it's just going to flip the identical image along the given axis, whether it's X and Y or Y and Z. It's for you to decide. If I go into mirror, it gives you the plane and it says I'm going to put another one on the other side of the plane. I can go and flip that, and all of a sudden I get a really cool shape, and both sides have been mirrored. You can change the plane tolerance. You can go into mirror append and mirror existing. So with mirror existing, it's just going to select what you have and flip it. It's not going to create any duplicates. I think it just makes sense to set that to mirror and append. And then you have a few alignments that help you to understand the position of your plane. So if you have difficulty reading through the delta mode and the gizmo, you can just experiment with those and get the result that you want. I'm going to go accept, and now I have a single mesh. All right, let's go into the last one, trim. To perform trim, we again need two objects. So I'm going to create a simple box. I'm going to bring a sphere, really doesn't matter. Bring this one in, and through delta mode, I'm going to ever so slightly push that in. So we get a little bit of geo-interpenetration on the geometry. So far, so good. And by the way, if these two gizmos get under your skin and you can't quite see what's going on, as soon as you click trim, you can actually hide them momentarily to focus on your model. But I'm going to go accept. Now select your model A, the first model, shift select your model B, your second model, and only then trim enables. I'm going to go trim, and what it does, simply, it cuts selected mesh with a second mesh. Kind of similar to what subtract A minus B does in Boolean. So if you're not comfortable using Boolean, you can certainly use that. So nothing too specific. You can switch. Instead of trimming B from A, you can go A from B. And now you can see I'm actually trimming right here. If you have difficulty seeing this box, you can increase the transparency. I'm just going to bump it up to 0.5 or maybe 0.8 so I can see things better. You can hide gizmos, the delta mode, if you don't want to see them, and you can comfortably press accept when you finish. I leave output type, output object, and on tool accept always as default. You can specify what type of output you want to get, static mesh, volume, or dynamic. No reason to get volume in this type of operation, but if the situation calls for it, only then change that. I'm going to set that from input, which is a static mesh. And for output object, it says we want to create a new object, first input object or last input object. So basically, whether you keep this or create a brand new on your outliner, which is always the best idea. So new object. Once you're happy, you click and you end up with a brand new static mesh called trim. And you can see I'm trimming B from A. And by the way, this, what you see, the object is in fact two-sided. The fact that we just see it like that is for optimization purposes. But rest assured, we do have a geometry, as you can see. Now that's going to conclude the model using predefined meshes, and we will work more with these tools, bring them into a real case study in the near future. But for now, understanding the tools and how we use them is actually quite important. I'm going to go into Polygroup edit just to inspect, to see what we have. And we do in fact get all of these guys still as individual polygroups, which you can now use to your advantage. So you can do pull, push that to the side and get something really interesting in no time at all. Let's go to the next chapter and talk about mesh, where we essentially try to move away from predefined meshes, and I'm going to bring a custom mesh from another application, and we see how we deal with polygroups when we have a brand new mesh from another application into Unreal Engine. The next category is called mesh, and we use this category mainly to optimize our mesh and to edit the properties of our mesh. Part of it can be done in model, but since we now know how to work with polygroups, we can actually target polygroups and do our editing. Now in the model we use predefined objects like sphere or box. Let's dive into another application, put something really quick together and bring it into Unreal, because with mesh, the main power of it reveals itself when you have actually a model coming from outside of Unreal Engine. So let's go into Autodesk Maya and put something really simple together. Here I am inside Autodesk Maya. In order not to deviate from the purpose of the video, I went ahead and put something really quick together. Let's call that a table, which goes well with our studio, hypothetically, of course. Let's combine everything. So I am going to go to Mesh and Combine. Let's call that Table. Export as FBX. FBX export is selected. I'm going to call that Table and Export Selection. Let's switch back to Unreal Engine, and I'm going to go to Content Drawer, right click, Import to Games, select Table and bring it over. I'm going to reset to default. The only change I'm going to make is I'm not going to bring in any material because that's irrelevant to what we're doing. We have the table and let's drag and drop that in. Perfect. I'm going to reposition it really quickly. All right, we have a brand new object coming from another application. And as I mentioned before, if I go into Model, Polygroup Edit, we have just one single polygroup. It's really difficult to make any edits on it because we cannot access to its components. Everything has been triangulated. I'm going to go to Attribute and Inspect. You can see it's been triangulated and we have a completely different mesh. So far so good, we know that already. Now let's go to Mesh and investigate what Try Select is about. Now Try Select allows you to select the components, create a polygroups. Out of your selection, we can make use of Selection Edits rollout. You can clear your selection, select everything, or clear it. You can have part of your selection and invert it, but the one that I use the most is grow and shrink. And that allows you to really select, maybe if I go and clear, let's say I'm going to select only one, and I'm going to use grow to select everything. In no time at all, I have the piece selected. Now do not press accept. First go and have a look in Mesh Edit and see if you want to make any adjustments. If you would like to duplicate that piece, if you would like to smooth it, disconnect it as a separate piece, delete it altogether, flip its normals. If you bring the model and it's black, knowing that normals have been flipped, or in my case, the one that I use the most is create polygroup. If I click on that, on the surface, not much is happening, but if I go accept and into model, polygroup edit, this one now is a separate polygroup. And you benefit that not only through your modeling process, you can actually UV unwrap a polygroup, so you don't need to tackle the entire combined geometry at once. And there are ways to actually bring that into the process of adding materials as well, and say only assign the material to this particular polygroup. So if you ask me, when you bring a mesh, think about if there is any area that you want to edit, it requires significant change in UV mapping, in materials, or in modeling, make that part a separate polygroup, and it makes your life a lot easier, trust me. I'm going to go into mesh and rinse and repeat a little bit, try select it, and use grow to do its magic. Create polygroup, accept. I'm going to use that trick again, grow, all done, create polygroup, accept. And even though this one must be a separate polygroup, I'm not going to take any risks. I'm going to select that bit and grow selection, polygroup. So making sure that it's all selected, create polygroup, accept. Let's check really quick through polygroup edit. And now you can see with individual bits and pieces, I can go into polygroup edit, and as the name suggests, I can perform these tools on each one of these polygroups. And that's the beauty of using these two together, because they're kinda related. One mesh creates the polygroup for you, and the other one, model, edits them for you. If you don't want to create polygroups and you feel like there are just few faces that you want to target, then in that case, you don't need to go into model, go into triangle edit instead. That is going to edit elements directly without caring about any polygroups. But of course, then you need to select individual elements, edges, points, or triangles manually. That is going to take a little bit of time. So if you ask me, convert everything into polygroups, go into model and edit them using polygroup edit. It's much more effective. It's a lot more accurate. But just for the sake of demonstration, to cover triangle edit as well, let's pay a visit to that. I'm going to go accept, go into mesh catalog, into tool palettes, and click on triangle edit. And as I said, it doesn't care about polygroups. It says, all right, you don't want to give me polygroups. That's fine. At least tell me what elements you want to work on. If I zoom in, this piece right here and this face, and I would like to extrude it. I'm going to press F to frame on it so I can see things better. I'm going to go to extrude, and it gives you the option to extrude it. While you have this face selected, you can go in there and make all sorts of adjustments. Let's say you want to delete your faces. Of course, it's going to go ahead and delete it for you. To bring this back, you need to fill hole, which is related to edges. So I'm going to switch my filter to edge, and I'm going to go fill hole, and I'm going to get that two triangles back. So there are other tools available in the mesh category. It's not just about editing triangles or creating polygroups. You can fill hole. You can create or perform a union. So you can merge objects This jacket is going to delete all the hidden triangles that you may have. More of a sanity check on what you have. Jacket can actually do a round of cleanup for you. Also, we have remesh and simplify, and those two are working against each other. They are kind of opposite. One adds resolution, one removes resolution. And because we're dealing with the optimization, what I suggest when you're working with these two, I always go into show, I go into advance, and I make sure that mesh edges is selected. So you kind of know what you have and what you're dealing with. There is an inspect button here, which is identical to attributes inspect, because you are actually optimizing the model and you need to know what's going on. But inspect is just one extra click if you want to have them permanent in your scene while you're preserving the shader. You can definitely make use of advanced mesh edges instead. Now, let's say I'm going to inspect this one and I feel like, yep, while this area works really well, if I ever want to deform this top portion through model polygroups edit, I may run into issues because the topology is not going to work in my favor. So I need to remesh that. The way that you remesh it is through remesh, and it gives you an instant preview what it wants to do. And you can actually dynamically go in there and change that. One issue that I tend to run into is some of these areas get really blobby. So you can see I'm kind of losing the shape of that. And although I put smooth type to shape preserving, I'm not really getting the result that I want. I believe the default is set to mix, and it doesn't matter what you change that to, even shape preserve is not going to give us the ideal result. So one solution I found is in your 3D application, make sure to either add crease or harden the edges when you create the model. See that thick line? That thick line indicates that I actually preserved the normals, hardened the normals in my other DCC, and I left this one alone to show you what's going to happen if you fail to do so. Nothing too major, to be honest with you. You can totally avoid that through your application, but I thought I'd mention it in case if you want to remesh your model. In that case, think ahead, plan ahead, and avoid this. Now, the other scenario applies where you feel like this resolution is too much and you would like to simplify it. Of course, you can always go into simplify, and it automatically simplifies the whole thing. Now you can see the default is QEM, and QEM is a bit aggressive. I really don't use that. Usually you will lose your silhouette. In this case, it didn't happen, but you can see the topology is just excruciating to watch. What I usually switch that to is minimal shape preserving. So it tries its best to keep the silhouette. You can see there's barely a change in the silhouette while reducing the triangles. So that's that as well. Inspect, we already know and love. And the other one is kind of a funny tool. Let me demonstrate how that works. I'm going to create a box. I'm going to put that box here. Why don't we, now we know where the remesh is, let's go and remesh that. See how we quickly brought other tools into use? That's good. With this one, let's say I want this to follow the curve that I'm seeing in this table. See that curve that I'm having? I used bend nonlinear deformer in Maya to make that happen. But let's say for whatever reason we forgot that there is a deform tool here with warp. You can pretty much do the same thing. Let's say we don't know about that tool and we want this to follow this one right here. You can kinda do that with project, although I have to admit the tool is not perfect. So first thing I want to do is to go to Xform and make sure I split the model, because it doesn't work with polygroups. It just looks at individual pieces. Now we have this one, and now we have this one. And now I'm going to go into Mesh and select both of them. The order is really important. So let's call this one object A, and this one is object B. We want object B to follow the silhouette of object A. So you select object B, and then you select your source, object A, and then you go project. And you can see right off the bat, we're getting something, but that something is not perfect. It gets even worse, believe me, if I switch to the default settings. So what you kind of need to do is to go to Advanced, Remesh Type, and I believe the default, if I bring the default back, is set to normal flow. And if you bring that to normal flow, you can see that everything is kind of freaking out. Switch to full pass, and it tries its best to follow the silhouette. You can increase the remesh iteration to get a slightly better result. Once it's done, you go accept, and if I now select that one box and bring it over, you can see that it kind of follows the silhouette, although it lost its thickness. I'm not going to spend too much time on Voxel. To be honest with you, the reason that we have this tool to begin with is to voxelize any geometry that you have, to remesh the geometry, fill any possible holes that you have in your model, and then give the model back to you as mesh again. So it's going to convert everything into voxel and then voxel mesh again. The reason I'm not a huge fan of this set of tools in here is because it deletes UVs. So be very careful. If you carefully UV edit everything in your other application, do not apply voxel because it's going to get rid of them. So you can see it gives you a representation. You can increase the voxel count. I'm going to enable auto simplify, and it's going to think. It turns my voxel into mesh. So now it's done its thing. I'm going to go accept, and you can see now I have a brand new mesh. You can see in the outliner it's a static mesh. However, I lost my UVs. Again, it's great if, let's say, you have a rock with lots of pores and holes and you would like to soften it, and for whatever reason you don't want to use sculpting tools to soften and fill holes. Voxel can be a good use, but again, you need to UV unwrap it. So that's a quick look at what mesh does and the purpose of voxel. Let's go to the next chapter. Now we're almost towards the end. There's only a handful of tools left that I need to go through, and from this point onward, the tool sets that you see, all the tools, are not the type of tools that you use on a daily basis. So the first one is the bake category, and the tool palettes that we have requires mainly a source mesh with textures and a target mesh without a texture. And the whole purpose behind this category is to transfer the pixel value information or images and bake that from source to target. Bake textures is going to bake the source mesh details, albedos, normals, tangent normals, and curvatures from source into target as texture. Bake vertex colors will disregard the texture part, and it's going to bake a source mesh details, all those maps that I mentioned, to the target mesh as vertex colors. The other one is bake all, and that is going to use multiple source meshes, get all of the textures, and try its best to bake that into a single target mesh. And bake RC, which I honestly never used, is based on Unreal description, bakes textures for target mesh from multiple source meshes. There is one guy here that requires a single selection of the mesh, like so, and that simply recomputes the tangents. So if there is any issue with your model and you would like to transfer or bake the texture to the target mesh, make sure to press tangent and it recomputes the tangents, sanity check the normals, and make sure the model is healthy, and as a result of that, the baking process goes smoother. And of course, the good old inspect is there simply because we need to inspect the normals here. This is just a very simple description of what this category does. In practice, it also is very simple. I've got a source mesh. You just need to think about what texture this source mesh uses. Again, we're not talking about the material, we're talking about the texture assigned to that material, either as a normal map or as a base color map, so on and so forth. So if I go and scroll down here, you can see I'm dealing with a material instance. I'm going to click on this folder with the magnifier right next to it to identify where the material is. I'm going to double click on it, and now you can see we are using IDs, we are using pack textures. Different textures are assigned to different channels, and we are using a normal map and a base color. What you need to remember is the name of the texture, which in my case is T_BS_ guest couch chair_DIDMN. That's all you need to remember. The process of baking is also important because you always select the target first and shift select the source, and then you go into bake textures, and the rest is fairly straightforward. Right now, the engine is not processing anything. This is red. Every time it's blue, it means it's healthy and it's processing. When it's red, it means that it's an error, insufficient information at this point. But let's go through all of that. Bake output, what you want to bake, tangent normals, object normals, which is the default, face normals, bend normals, position, curvature. We actually want texture, so I'm just going to disable object normals, leave it as texture. Preview output, always leave that as texture, because even if you set normals, you would like to see the look of the normal as a texture on the model. Then we're talking about the resolution. So 256 is what you have. You can bump it up to, let's say, 1024. Definitely inspect to see what texture resolution you're using and try to kind of match that. And it says bake input, UVs, channel 0. Sometimes the target mesh or source mesh, they put everything into UV set 1. So something to check. The default setting is actually UV0. So if you don't know what I'm talking about, chances are UV0 is correct. Now, the reason that it's red is because of the texture output. And you can see it says the source texture is not valid because we haven't specified what exactly we want to transfer from source into target. So the way that you do it, you select the target, you select the source, which we've already done, and you go in here and you search for that texture that I just talked about. I'm going to copy paste that, and you can see we have D, ID, M, and N. N for normals, D for diffuse, and if I click that, you can see I'm getting only the texture baked on the target mesh. Not ideal, to be honest with you, because what we're missing at this point is physical shader attributes not being present on this target mesh. The benefit is it's a lot faster to process if you're working on games and the engine cannot handle physical attributes of any shaders. That's all there is to it. If I go cancel, you can pretty much do the same thing in here as well. Output mode, RGBA, what type of texture you would like to bake, and the preview, again RGBA. And just like the previous tool, you go into texture output, you select that, you search for the texture that you want. Let's say in this case, again, diffuse, and the color information per pixel will be baked on vertices. And that's why we get a little bit of artifacts here. The next one is UVs, and this is a big topic, and I already have a video on my Unreal Engine series dedicated to that topic. It's a bit old and the layout is different, but I sanity checked that really quickly to make sure there is nothing new. And in fact, all the tools that I explain in that video, they're still valid in here. So definitely check that out. Click on the link below and find that in my Unreal Engine YouTube playlist to be able to understand how this works. It leaves us with attribute, and we've already looked after inspect. Now that leaves us with only one category. We already talked about inspect, which is probably the most used command or tool in here. Not every single one of these are directly applicable to your modeling repertoire. For example, managing level of details is not something that you do, especially with the introduction of nanite. Computing tangents or normals, I would like to think that you will check those in your original application before you bring it here, or even if you start from scratch in here, there's a very slim chance that things go wrong with your tangents or normals unless you do something really odd. The one that I use is generate polygroups, and the cool thing about that compared to other tools that we've already learned is if I click on that, you can actually use the conversion mode and tap into the quad modeling generation that you relied on in, let's say, Blender, Max, or Maya. How? If I go in here, you can see find quads, and all of a sudden you're retrieving the original structure without triangulating anything. And Unreal Engine is sort of allowing you, if you would like to apply Polygroup IDs into every single quad. Another cool thing is, remember I said with polygroups, you can use that in conjunction with your UVs. So that one is here from UV Island. So if you UV unwrap in your 3D application and that looks correct, you're kind of in luck. What we did with mesh and model to create polygroups was kind of irrelevant, since when I made that model, I UV unwrapped everything really quickly. So you can see we have 1, 2, 3, 4 polygroups as expected. You have other modes as well, from hard normal seams. You remember that I said I harden the edges on each piece. The thickness gets a polygroup, thickness here and here they get polygroup, and these guys get separate polygroup IDs. And you take that from there. That's how you actually separate those into polygroups. If I go accept and go into model polygroup, you can see all of these guys are in fact a separate polygroup. I would say that's the one that I use the most in attribute apart from inspect. There is another one which is called edit material. And with edit material, as long as you have a separate polygroup, you can actually apply material only to that polygroup. Let's bring, for simplicity's sake, let's bring just a predefined model like box. I'm going to press F on it and press accept. Let's go into attributes, and this is the one that we are going to talk about. Edit materials. Well, the purpose is to adjust your brush, select a polygroup, and then create a material and assign that only to the selected polygroup. So I've selected only 2 triangles just to demonstrate. We don't have any material, so you go add elements. Let's bring a material. I'm going to search for wood, the same material that I assigned to the floor. And it's important not to overwrite what we already have, so make sure that one is untouched and add one, because this one is in charge of putting these materials there. If you remove that, then your default material is going to be whatever you create. So have that as a reserved material, create a new one, and then in active material, let's go and switch to wood. That's the one that we're going to assign to the polygroup. Now the hard part is done. Just go ahead and assign material. And done. We have the material assigned. At any point of time, if you would like to continue with that and change it, you certainly can. I'm going to assign a different type of wood. Let's say this one. I'm going to switch to number 2, and I'm going to go assign material and rinse and repeat. So you can see how simple that is to color faces using polygroups inside Unreal Engine. Once you're happy, you accept, and you're good to go. There is really not much else in there for me to talk about, and I hope these 2 videos that you hopefully have watched back to back give you a solid understanding on how modeling works inside Unreal Engine 5.4. Start experimenting. I highly encourage you to put those tools into practice. Again, as usual, follow me on Reddit, X, and Instagram. Thank you very much for all of your support. Have a great rest of your day, and until the next video, see you guys later.